Okay, class. Good afternoon. So this is another presentation in engineering economy. So the topic here to be discussed is the ordinary annuity. Okay. So what is an annuity? So let us first define what is a definition of an annuity. So annuity, so it is a series of equal payments made at equal interval of time. So it is very clear that an annuity is a series of equal payments made at equal interval of time. Okay. So where does this annuity applied? Okay. So this is applied for amortization. So what is an amortization? Of course, if you are paying a debt, the lending company will produce an amortization schedule for your loans. So the amortization schedule defines what is supposed to be your payment at the end of any time, monthly, yearly, or whatsoever. Another application for this is insurance premiums, sinking fund, scholarship, depreciation, and so on and so forth. But actually, annuity is divided into several types. First is the so-called ordinary annuity. The next is annuity due. And the other is the so-called deferred annuity. So by this time, we are just only discuss the ordinary annuity to make it clear or to make a discussion which is uh, clear. Okay? So let us consider a cash flow diagram. Okay. So in this cash flow diagram, so at 0 year, so there is a principal amount P, wherein this P is equivalent to a future amount at the end of time. Okay? So here, at the end of 5 years. So there is a projected amount. Of course, if there is a percentage interest, monthly, yearly, or whatsoever. So let us now, instead of just getting the value of F, we replace this F by a yearly payments, which is at 1, we are going to pay an amount of A. Another is at 2, A, at 3, up to the last part of the last term of payments or at the end of the year. Okay. So, let us consider the last payment at the end of the 5th year as the first term. Okay? So, knowing a so-called a geometric progression. Okay? So, why is it we are designating that as the first term? So, because if we are going to get the common ratio for a geometric progression, so that is, of course, it's required to know what is the second term and what is the first term. Okay? So, and the payment at the end of the 4 years as the second term. And at 3, the third term. At 2, the fourth term. And at 1, that is the fifth term. Okay? So, wherein at 5 years, or at the fifth year, okay, the amount, of course, of A which is required to pay at the end of 5 years is only A. Okay? So, but at 4, the amount of A, if we bring that to fifth year, that is equivalent to A multiplied by 1 plus I raised to 1. So, raised to 1 because that is 1 year. And at 3, the third term, the future amount of that A is equivalent to A multiplied by 1 plus I raised to 2. Okay? And so on and so forth. Okay, so let us now consider that as a geometric progression. Okay? So, wherein the sum of the geometric progression is equivalent to the first term multiplied by the common ratio raised to the number of years, or n, minus 1 all over the ratio, or common ratio rather, minus 1. So let us now consider the first term, or the second term rather, and getting the common ratio. So the second term, okay, so this is no longer the second term, but the first term, okay? Or the third term rather. Where the third term is A multiplied by 1 plus I raised to 2. And the second term is A multiplied by 1 plus I, okay, raised to 1. So, as seen on the previous slides in the cash flow diagram. So, the common ratio now is 1 plus I, okay? So, eliminating A and 1 plus I, okay? So, that is the common ratio. So, substituting now, of course, from the formula of S, the first term is A, the common ratio in 1 plus I, raised to N, minus 1 all over I. Okay? So, knowing also that F from compound interest equals to P multiplied by 1 plus I raised to N. And then substituting the values from the formula for the sum of the geometric progression, now the value of P is equals to A multiplied by 1 plus I raised to N minus 1 all over I. So take note, this is the present amount. So sum is the future amount. Okay? So next. So where another, F is also the equal to future amount of the annuity and P is the present amount. The factor 1 plus I raised to N minus 1 all over I is called uniform series compound amount factor. And the factor for the present amount, which is 1 plus I raised to N minus 1 all over 1 plus I raised to N times I, is called uniform series present worth factor. Okay? So, take note of that. Okay, so let us consider an example for this ordinary annuity. Okay? So, let us now take this. The reliable motor works purchased a synchronous motor from the General Electric Company, valued at 25,000 pesos. Okay. On an easy payment plan, as 20% cash upon delivery of the motor, and the balance to be paid in 24 monthly installments, with 12% nominal interest on the unpaid balance. Okay. A. How much would the RMW, or the Reliable Motor Works, pay each month to the General Electric Company? Okay. And another is, if instead of the above terms, the RMW decided to start a sinking fund to enable it to purchase the same motor after 2 years on cash basis at the same value, least 10% discount for cash purchase, how much with the monthly deposit and the fund B. So if the money will earn interest at 6%, assume interest rate are compounded monthly. Okay? Okay. So, let us now take the solution. Okay. So, from the cash flow diagram, so 20,000, and then the end of 2 years, you will pay an amount equivalent to the annuity A. Okay? So, getting now the value of A from the formula on the previous slides for present amount, P is equals to A multiplied by 1 plus I raised to n minus 1 multiplied by 1 plus I raised to n minus 1, or the present worth factor. A now is equal to 941.47. So you will pay at the end of the month for 2 years an amount of 941.47 pesos. Okay? Okay. So getting now the future amount. F. So 25,000.9, okay, was 22,500. Or the future now is equivalent to 884 point, or the annuity rather, getting the annuity, okay. So 884.71. That is the second condition. Okay. So we have another example. The refrigeration equipment rather, fabricator sold on ice drop making machine with a condition that in case the machine will not be able to produce a guaranteed capacity, he will deduct from the agreed price of the machine the loss of revenue that the buyer will incur during the economic life of the machines, which is set at 5 years, plus 12% cost of money. So 1 month after the machine was delivered, the buyer complained to the fabricator that he is not getting the guaranteed production. After a series of tests, it was determined that the buyer would be losing 4,000 worth of unrealized sales per year. So, assuming no increase in operation cost, if guaranteed production were attained, how much must the buyer deduct from the agreed price of the machine? Take note, it is board examination 1985. Okay? So, solution. So, the amount to be deducted, of course, is equals to the present worth of the annual losses. So, from the definition of the present worth of the annuity, A now is equals to 14,419.1. Okay? So, last example. So, a farmer bought a tractor costing 12,000. If paid in cash, the tractor may also be purchased by installment to be paid within 5 years. So, money is worth 8% compounded annually. Determine the amount of its annual payment if all payments are made at the end of each of the 5 years. Okay? So, again. So, let us consider the cash flow diagram. So, the 12,000. And then, the end of 5 years, so we are going to pay an amount of A. Okay? So, getting now A, the amount is 3,005.48 pesos. Thank you very much. So, that ends the discussion on ordinary annuity.